All right, so next we're going to look at using the one-to-one property of logarithms to solve logarithmic equations. So we have here, it says express the equation in the form log base b of m equals to log base b of n. This form involves a single logarithm whose coefficient is 1 on each side of the equation. Use the one-to-one logarithm to rewrite the equation without logarithms. So what this is saying, we're going to go back to how we talked about using the one-to-one property whenever we had an exponential equation. Well, this time it says here, if your logs, and here we have a common log with the base b, if they match, then our focus will be on this m and the n. And then we will solve the equation. Number 4 here, it says check proposed solution in the original equation. Include in the solution set only values for which m is greater than 0 and n is greater than 0. So whenever we check our work, we want this m and n to be positive numbers, or we want it to be greater than 0. Okay, so i.e. positive numbers. All right, so let's take a look at an example. We have here, it says solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithmic expression. Give the exact answer. So here we have log of x plus 10. The quantity of x plus 10 is equal to log of x plus log of 10. So our goal, first of all, is to have the logs by itself on each side. Okay, we want to log on the left side just 1, and we want to log on the right side just 1, expressing that as one logarithm. So that means we will have to work on the right hand side of this equation because we want this to be a single log on the right hand side. Therefore, let's go back to our properties of logarithms. We have the product rule, we have the quotient rule, and we have the power rule. Well, because this is a positive, we're going to be using the product rule, where because we're adding two logs together, so we can convert this, condense this down to one log, where it will be log base x times 10, and we know that is going to be x times 10 would be 10x. So here we have log of x plus 10 equals to log of 10x. Now with this property, we have a log and a log. They are the same with the common base. Remember, when the base is not there, it's understood to be 10. So now that we have the logs on each side, we can drop the logs, focus on the x plus 10 equals to 10x, and then we're going to solve for x by subtracting x to both sides. We have 10 is equal to 9x. Divide 9 to both sides, and we have x is equal to positive 10 over 9. Now we can go back, plug 10 over 9 into our original equation, but as we substitute 10 over 9 in for x, it is positive. Therefore, 10 over 9 is greater than 0, i.e. this is our final answer. Let's do another example. We're going to solve the logarithmic equation, and we're going to use the one-to-one property to solve this. So here again, for this example, log of x plus log of x minus 2 equals to log of 15. We want to condense. Make sure both sides are condensed in condensed form. So the right-hand side we need to not convince, but condense. So we're going to use the product rule again, where we're going to multiply our x and our x minus 2. On the left-hand side, this x times x minus 2, we can distribute. We have x squared minus 2x equals to, we have log of x squared minus 2x equals to log of 15. Using the one-to-one property, now that each side they're condensed, we can drop the logs and let's focus on the x squared minus 2x equals to 15. So now we're going to take this equation, set it equal to 0 by subtracting 15 to both sides. And either we can factor or we can use the quadratic formula to find x. So we're going to factor. What are factors of negative 15? That when we add those factors, it would give us negative 2. So fill in the variable component. Factors of 15, we have 5 and 3, and we want negative 2, so the 5 is going to be negative, the 3 is going to be positive. Then we're going to set each factor equal to 0 and solve. So x minus 5 equals to 0, therefore x is positive 5. X plus 3 equals to 0, therefore x is equal to negative 3. Now, remember, when we go back, substitute each of our solutions into the equation. Here, when we substitute 5 in for x, it leaves our answer component here as positive. So 5 minus 2 gives us 3. So this is a solution. But here we have negative 3. And remember, we don't want our m, nor do we want our n to be negative. Therefore, we're going to reject the negative 3. So our solution here is positive 5. Next example, we have ln of x minus 8 plus ln of x plus 2, excuse me, x plus 1 equals to ln of x minus 24. Let's condense the right side by using the product rule. Excuse me, the left side using the product rule. And then we have here ln of x minus 8 times x plus 1 equals to our right hand side ln of x minus 24. So the left hand side ln of x minus 8 times x plus 1, we want to FOIL. So we have x squared plus x minus 8x minus 8. So then that will give us ln of x squared minus 7x minus 8 on the left hand side equals to ln of x minus 24. Now, these are natural logs, but the rule will still apply. We're going to use the one-to-one property. So the ln's divide, we can cancel those out. And then we have x squared minus 7x minus 8 equals to x minus 24. All right, so we're going to subtract x to both sides, and we're going to add 24 to both sides. Okay, so let's go ahead and set the right side equal to 0. And we have x squared minus 8x. And then we have negative 8 plus 24. That gives us 16. Okay. Now we're going to solve this trinomial, this quadratic equation by factoring. X and x minus minus, or the factors of 16 that will add to give us, those numbers will add to give us negative 8. We have 4 and 4. So we have here the quantity of x minus 4 squared is equal to 0. And to solve for x, we take the square root to both sides because we want to get rid of the exponent of 2. And we have x minus 4 is equal to, we would say plus or minus 0, but plus or minus 0, when we take the square root of it, it's just going to be 0. Therefore, x is equal to 4. Now, at this point, check your solution. So we're going to go in and plug 4 into our original equation. And when we say 4 minus 8, that gives us negative 4. We do not want this to be a negative number. And even if we substitute 4 in on the right hand side for x, that would give us negative 20. So what do you think our solution would be if 4 does not work? We would say no solution to this example.